Hydrostatics 2018, question 9, part B. A thin uniform rod AB of length 2h, just let's highlight some of the variables given to us, of length 2h and weight W, can turn freely around end A, which is fixed at a height h above the water into which the other end dips. The rod is in equilibrium when inclined at 45 to the vertical, which was given to us in this diagram underneath. Now, a height h above the water, this will come in later in the question. That obviously has to be 45 too, so this will be h as well. So that will help us later on in the question. So what we're going to do in this question is we're going to let x is the fraction of the rod below. So 1 minus x is the fraction of the rod above. And 2016 question 9 part B is pretty much the same question, and you can do them both exactly the same way if you follow this process. So we're going to draw a bigger diagram here. So just to go back up again, one last thing, find the relative density of the rod. So we're looking for S. So S is going to come in here, isn't it, with the buoyancy, when we're looking up and down here, with the buoyancy of the rod in water. So let's do a bigger diagram. Imagine this is the surface of the water, and this is the rod. What did they tell us about point A? It can turn freely around A. We'll call the force going up here F. There's a force halfway down here, halfway down here. We know these distances. This is x over 2 and x over 2. This is 1 minus x over 2 and 1 minus x over 2. So when we get moments about this point, we'll call this point here what we call a Q. When we get moments about this point, we'll be using the distances. So what's going on here? We have the buoyancy of this rod in water, and buoyancy is equal to the weight over the density of the object. Now we have a fraction of it immersed, so we'll have to multiply that by x. We also have the weight of the object here, and the fraction of it coming down, well, it's 1 minus x, which is above the water. Do we have anything else? We have, obviously, we have buoyancy down here. We have x times the weight, xw. So the two forces going down based on weight are 1 minus x times the weight and x times the weight, which is obviously going to be the weight. So let's look at the moments about Q. So the moments about this point, the midpoint underneath. So what we have going on here is we have the distance of the force away from Q. So we start with this one. How far is that away? W times 1 minus x is from here to here, plus from here to here. So that's 1 minus x over 2 plus x over 2, and that's going to be equal, that's the only force coming down, that's going to be equal to the force going up here around A, which is F, and the distance F is away from Q is the total distance above, which is 1 minus x, plus the distance below, which is x over 2. Now what you need to do in these questions is simplify this down to get F is equal to, and then when we're looking at our forces, we'll get F is equal to, and we'll equate the two equations. So what have we got here? W times 1 minus x times, if I break this fraction up, you can see we're going to have a minus x over 2 and a plus x over 2. So we can cancel them. And then we're going to have equals F times, well, let's make this a fraction. F times 2 by 1 minus x, which is 2 minus 2x. That 2 by that one, and then plus 1 times x, which is x, over 1 by 2 on the bottom. So tidy this up, we get W times 1 minus x times a half, or just over 2, equals F times 2 minus 2x, 2 minus x over 2. So to get f on its own, we're going to divide w times 1 minus x over 2 by 2 minus x over 2, which we'll have to turn upside down and multiply. So f will become w times 1 minus x over 2 times 2 over 2 minus x. 2 over 2 minus x. So the 2's cancel, leaving f being w times 1 minus x over 2 minus x. So let's go back and look at our forces. Let me start these over on the left here. So the forces at play. Going up and down. So what have we got going up? We have this guy. We have the buoyancy, which is wx over s. And we have our force, just F. So there are the two going up. F plus x w over s. They're equal to the ones going down. This one here, w times 1 minus x and x times w. So w, and you can see what these are going to simplify to be. W times 1 minus x plus x times w. So we get rid of the bracket on the right. F plus xw over s, which is what we're looking for, is equal to w minus wx plus wx. So we're going to get f is equal to w minus x times w over the relative density. And if we factorize out w, it'll probably make sense here. So f is equal to w times 1 minus x over s. And now we can equate these two equations. Can we see them both? So here they are here. This one and this one will have to be equal. So w times 1 minus x over s equals w times 1 minus x over 2 minus x. So what's going to happen here? Well, my w's will cancel, and we're going to simplify it down in x. So let's look at simplifying this down. The left hand side is going to become, let's write two algebraic fractions, s minus x over s, and that's going to be equal to 1 minus x over 2 minus x. So we're going to have s minus x times 2 minus x equals s minus sx. So we're going to have 2s minus xs minus 2x plus x squared is equal to s minus xs. So they'll cancel that one and that one. So what am I left with? I'm left with x squared minus 2x, and if I bring that s across, I'm going to just be left with plus s equals 0. So if I think I'll use the completing the square method. If we get x minus 1 to be squared, that's x squared minus 2x plus 1. So we brought this plus 1 in that we don't want, so I'm going to have to take away 1. The s is still there. So I'm going to get x minus 1 to be squared equals 1 minus s. So x minus 1 is equal to the square root of 1 minus s. So now we have x is equal to 1. Well, that should be plus or minus, shouldn't it? Put my plus or minus in and we'll see which one we're going to use. So 1 plus or minus the square root of 1 minus s. Only one of these solutions will work. As this is positive, adding it to 1 will make x greater than 1, which we can't have. So the solution is always going to be 1 minus the square root of s. Now we allowed 1 minus x to be the fraction above. So what is 1 minus x? 1 minus x is equal to, well, just bring that across, the square root of 1 minus s. So the overall length above is the fraction of the length above, 1 minus x. Well, in this case, we'll use 1 minus s because we're trying to solve for s multiplied by the total length, which is 2h. So going back up to the diagram, why those h's were important at the beginning. These h's in blue here, this one and this one, is we now have a triangle where we have the three lengths in terms of h, and there's an s in there. So if we draw that triangle out and solve it, we should solve for s. So we had h, and we had 2h times the square root of 1 minus s. So using Pythagoras, h squared plus h squared is equal to 2h by the square root of 1 minus s to be squared, and that's a product, so we can square both individually. So 2h squared is equal to 4h squared by 1 minus s. So if I divide by 4h squared, I'm going to get 2h squared over 4h squared, 2h squared over 4h squared, which is 2 over 4, or 1 over 2. So 1 over 2 is equal to 1 minus s, which would leave s being a half. So a nice way to do this question. Try 2016 part B using the same method, and hopefully you'll have success.